It's my pleasure to present Kian. He and I, we were working during this summer on a project that is related to solar flares. So this is very difficult, very different from astrophysics in many ways. And I think it was really a pleasure. I was very surprised with the different results and how Kian worked during this summer. So I will let Kian to explain the project.
Thank you, Dr. Juan Carlos. I just before I get into the presentation, I want to thank you for all your help during this process. It was really very helpful and everything, and I appreciate everything you've done to guide me through this process. And I would also like to thank this not this, but the N3 internship overall for giving me this opportunity to present the research that me and Dr. Juan Carlos have come to put together for all of you to see right now. And I will share my screen right now. Okay. Can you guys hear me and see me?
Great, it's looking good.
All right, all right, all right. I think this. So, this is us on a hunt for white light flares. So, first things off, we're going to start off with the abstract. I am Kian Miranda Rodriguez, and let's get started. So, what are solar flares? So, solar flares, think of them as an explosive phenomena in the sun. And the white light flares are a category of such events seen in the white light continuum. In this work, we present the results of the analysis of, in total, 455 solar flares in our catalog, which is the site right over here. And from our results, we found 109 white light flares in the sample, while 33 of those flares show a coronal component. So what I mean by that is with the coronal component, if you're looking at a white light flare from a distance, so if you look at this video in the bottom, we'll get to that in a minute. Think of that, that's what the coronal component, if you're using a radar, that's what it looks like. And you can see the flare right on the bottom right over there, but we'll get into that, like I said. So here are the scientific questions and the motivation for this assignment. So the goal is to understand the conceptual idea of how the flares and white light flares are generated, and how hard X-ray and white light emissions relate. That's the question. Are all flares white light flares? Do all flares have a white light coronal counterpart? But to answer what white light flares even are, you guys might be wondering, Kian, what the heck are white light flares? Well, white light flares are, think of them as explosive releases of magnetic energy in the corona of the sun. Flares are particle accelerators, and their process starts with magnetic energy, then it leads to direct heating. But it could also have a significant fraction of that energy that moves at the speed of light into non-thermal particles, which soon turns into direct heating. So on the top right over here, we have 6 observations of the flare itself. So first off, I'm going to read the description. Large solar flare observed in the red light hydrogen alpha, showing 2 extended parallel flare ribbons in the chromosphere. Each image is 200 million meters in width, subtending an angle of 300 arc seconds, or about 1/6 of the angular extent of the sun. These photographs were taken at the Big Bear Solar Observatory on April 29th, 1998. And if you look very carefully at these images right over here, if you look at the image in the bottom left corner, so I don't know if you can see my mouse, but if you look over here, if you see this white flashing energy right over here, that's a white light flare. And I'll play the video on the bottom. There's no sound, so you don't have to worry. So it's very brief, but if you look in this corner right over here, you saw that flash of light right over there. The magnetic energy is coming together, and therefore that causes a white light flare. Right up there, you can see the process, you see it spreading. So that happens in the corona of the sun, right over here. And it looks almost like a ring as well. Just in the bottom, if you can see it, It's right over here. And we could just move on. So what are the results from this project? Well, I made a bar chart over here. It's a little hard to see, but I'll go over it. So the bar chart below shows how many flares in the original catalog are white light flares and how many of those present a coronal counterpart. So from these results, it's clear that only 1/3 of all flares are white light flares, and only a fraction of those present coronal features. So if you look very carefully from the chart, it's a little hard to see. The blue in the chart represents all the white light flares that are found from the years 2011 to 2016, but unfortunately, I found no white light flares in the year 2016 because there weren't that many solar flares recorded from there. Then we also have the red part of the bar graph. Those are the solar flares that I have not found a white light flare in any of them. And if you look, it's a lot. So when I was looking through all the solar flares in the catalog, I found a lot of empty things, really. I didn't find any white light flares. So that would happen a lot. And the yellow represents the coronal counterparts. So that means that there are white light flares, but in the coronal, well, when it presents the coronal features. So the radial distribution of flares, which is the chart over here, demonstrate that most of the flares are located close to the limb. We believe that this is because the signal to noise ratio of the flare coronals is better at large longitudes. So again, this is the same recording from the years 2011, but to this time 2015, because I didn't find any recorded white light flares. So this chart is just representing like the amount of white light flares were recorded from those years. And now we move on to the conclusions, finally. So what are some things that I've learned from this project overall? Well, I've learned that not all flares are white light flares, and only 102 flares in the 455 flare sample show a white light component. From those, only a fraction, so just a small fraction, 33% present a coronal component. The flares happen very quickly in less than a few minutes, which makes it easier to miss at first. So if you just blink and you're like trying to like watch the sample, you're gonna miss it. It's just that quick. And the flares happen in, oh, I already said this. The flares appear as quick as a flash of light and then it would disappear. So again, like I said before. And another thing that's really important, the sizes are usually different, whether they are big or small, and it can happen anywhere. There's no, I don't think there's like a logical reason for that, why it does that. Maybe it's the amount of magnetic energy involved in that, but they do come in different sizes. So you're looking at the coronal component over here, right over here, when we were watching it over here, it was massive. Like this is a massive white light flare right over here. That energy, incredible. And the last thing that I've learned is that they show up on the coronal mass recordings and the standard recordings as well. And that concludes my presentation. Thank you very much. And thank you again for watching.